Hi everyone, my name is Pranshu Dumra. Today I am here to describe my task 1.1p, which is a moon robot simulation. In this task, I have implemented a proof of concept of moon robot simulation. The goal is just to demonstrate a robot that can successfully navigate a square grid of up to 100 by 100 grid size, strictly adhering to the boundary constraints to prevent it falling from the map. Let's just go to the code section. Starting at the top, I am using static system.console and system.convert. This is the basic one, which is a nice shortcut in C# that lets me call methods like writeline and 2 and 32, directly keeping the code clean and readable. Now let's jump to the main entry point. In the main method, the first thing we do is ask the user for a grid size anywhere from 2 to 100 units. We validate this input immediately. If it's out of range, the program ends. Then this ensures our simulation environment is stable from the just from the starting. Now we can notice the 4 variables. These track the robot's state. The boolean which is placed is especially important. It acts as a safety gate. The robot cannot move or rotate until it has been officially placed on the map using this specific command. Then coming to the command logic, now we enter the execute command loop. This is a while loop that keeps the program alive waiting for user input. If you type exit, the loop breaks and the program closes. Now the most complex input is the place command. In this process place command method, we use string.split to chop up the user's input. For example, if you type place 1 2 north by adding the commas, the code pulls out the 1 and the 2 and the direction. We wrap this in a try-catch block so that if a user types a typo, the program doesn't crash. It just politely tells them the format was wrong. Now let's look at how the robot actually moves. In process move command, we use a switch statement based on the current direction. If the robot faces north, we increment the y-axis. If it faces east, we increment the x-axis. But here's the most important part, the boundary check. Before updating the robot's actual position, we calculate the next position. If that position is outside the grid, like less than 0 or greater than the grid size, that is 100, we block the move or show an error. This prevents our robot from driving off into the vacuum of the space. For rotation, instead of using complex math, I've used a simple logic array. We define the sequence of the direction north, west, south, east, and simply move the index forward or backward to change where the robot is facing. Finally, we have the render grid method. This gives the user visual feedback. It uses nested for loop to print a grid of dots. I have written a special switch here that assigns a symbol like a caret for north or an arrow for east, so you can see exactly where the robot is and which way it's pointing. Now overall, this program demonstrates core programming concepts like input validation, state management, error handling, and 2D coordinate logic. Now let's quickly see the output of this code. First, giving the command .NET run to run the program. Now, as we can see, this asks the user to enter the map size. Let's give a grid of 5 by 5. Now, this is the command to place the robot. Like first, we'll enter place, then the point for the x-axis, like we can say 2. It must not be out of the grid. Then comma 4, comma, then we have to give the direction. We can say west. Now we can see the robot is placed at the 2 and the 4 point facing the west. Now we need to rotate it, or we can say first we'll move it. We'll give the command move. We can see it has moved one step forward to the west side. Then we'll rotate it. After the rotation, it should face south. Sorry, we have to write left. So we can see that now the robot is facing south. Now we'll again write move. It'll move one step towards south. Now if we want to move it towards right, it'll again face west, as we can see in the code. Now just to exit this code, we'll just type exit. It'll break the loop, as I've said earlier. We can see the program has braked and its process, and this was all. Thank you so much.